Yeah.
Could you end up with really cracking that nut?
That's a really good question. Well, so first of all, unfortunately, we deal with some physical limits, right? You need a certain amount of energy to get from A to B, and you try and minimize all the losses along the way. I think we're making strides in the right direction. We do have some good RF talent at Michigan, and the most recent Phoenix processor, the most recent intraocular processor that's being presented at ICCC this month, actually has an onboard radio. It has an integrated antenna that's on this little millimeter scale device. I would have loved to show you guys the pictures. It's really incredible. It's the first step, but that goes.
But it was near field. When you waffled over, you said the word.
Well, so yeah, it's actually this one is not near field, I believe. So I wasn't involved in that particular radio design. It's a weird little radio, but it's not a near field radio. But it is only. So it's close in terms of distance. It's only 10 centimeters or 15 centimeters in terms of communication distance. That's a far cry from a mile or something like that. It's good for, I got a doctor with a wand and I'm like, PKPI, right? That's a step in the right direction. We're not there yet. I think it has to come from not only better radio design, but better use of the radio. I mean, you can't be communicating once every second. Do as much local processing as you can. Mesh networks make it a heck of a lot easier because you can go node to node. One of the big problems there is synchronization. So I don't want all of my receivers to be awake all the time listening for this other guy. Otherwise, that defeats the purpose of the low power system. So what you need is good synchronization to wake everything up periodically. That puts the burden on timer. So we talked about timer earlier. It's tough to get really good synchronization. So that's another research problem that we continue to focus on. So I guess the point I'm making is it's not just a radio problem. It's an entire system problem.
Well, that was why I said it has to be done in cooperation across even UT centers.
Yeah.
And companies.
So I think
sponsors
it's
of
possible.
events, which are some of the like Freescale.
Sure. I think it's possible. I mean, I think we'll get there. I don't know. It's not going to be next year, but I think we'll get there. And I think you're right. It's a collaborative solution. Any other questions?
So now, how many employees in your company?
Well, we're young. We're new to the area, as I said. We are. I can't give you a precise count because we have some employment offers out. I am the only currently full-time person in Austin. We've got people elsewhere, but I'm the only person in Austin at the moment. So that is about to change, which is exciting. So we do have an office, as I said. We showed the picture of it. We're designing. We have design underway, which is exciting. So we're moving forward. It's an exciting time to be. There aren't too many chip startup companies these days. It's tough to raise money for a chip company. It's not as sexy as it was 10 years ago. And so there just aren't that many of these opportunities arising. So I would come talk with me. I'm happy to talk about the company, about the process it took to get it started, or job opportunities and those sorts of things. So, well, thanks everybody for your well.
One more. Did you ever look at using an asynchronous CPU design?
Asynchronous design?
Yeah.
We considered it briefly, and it's interesting. It's definitely interesting. It's interesting as a way to counter low voltage plus asynchronous is really interesting because asynchronous is more robust to process variations, and so that would allow us to maybe really push the limits of low voltage operation without really compromising robustness. So I think it's attractive from that perspective. We never really went down that road in terms of implementation, and I can't say there's a great reason why. There were just other things to go track down, but I think it's a good direction for sure. And there's certainly been some groups that have pursued asynchronous for low power. I like it. I'm not a huge fan of, if I was going to do asynchronous, I'd want it to be opaque to me. I want to use standard flows, and I would use a standard ARM architecture. So that for me to use that, it would have to be easily implemented, something that I just don't even know about. It would have to look like a synchronous design.
Okay, all right. With that, thanks our speaker.